Kids, keep quiet. Just move out of this room.
ये जो काम कहती है नहीं होता है क्या? बुरा नहीं.
Rajiv and Kelvin, good evening. Am I audible to you? Sir is not there, it's ma'am this side. Okay, Rajiv, Kelvin, shall we start or should we wait for another 1 or 2 minutes? Okay, we'll just wait for 2 minutes, okay, and then we'll just start. Maybe people may be stuck in the traffic, so let us give them this advantage, benefit of doubt, and we'll just start in 2 minutes from now. Today we are going to study about, Kelvin, you were there in the previous classes, so you are already aware what we are studying right now. Rajiv, I don't think you have attended the last few classes with me. So you have missed out on a very important topic. Now we are going to do the production function with 2 factors. Okay, Kelvin, is that fine? Production function with 2 factors. Yesterday we did production function with 1 factor. Is that so, Kelvin? Can you just revise for me? What is production function with 1 factor? What does it? What is this whole thing about? Can you just write in precise form? Kelvin, can you hear me? So Rajiv, we are discussing about the production function. That is the what is production and how is it done? Like how is it done? That is a mechanical thing that is done by the machines. But what is its implication in economics? What is the point of optimum production for the firm, for the producer? That is what we have covered in one of the previous classes. So we have discussed about a thing that is the production function in the short run. Short run means a period within a year. It can be, yes, that's correct, Rajiv. In the finished product, yeah. So we have discussed about production function in the short run. So in the short run, production function is like we use the inputs for production and these inputs are, good evening Prabha, welcome to class. So these these factors are fixed in the short run but variable in the long run. So we have discussed one part of it in the previous session. You can just go through the previous recording and get hold of that thing. Okay. Now today we will be studying the second aspect of this theory, that is the producer's equilibrium, or rather the production function with two variable factors. Okay. Prabha, can you just explain what is the meaning of variable factor? Prabha and Kelvin, this is for both of you. What is the meaning of variable factor? Vary according to the quantity of production. Yes, Rajiv, that's correct. And Prabha, that is also right. It is a variable factor is the factor which keeps on changing, which we can change according to our requirement. We can increase or decrease that factor. So which is the variable factor of production? Which factor do we consider to be variable? Rajiv, can you first tell me the 4 factors of production? Prabha, everybody? Prabha, Kelvin? Can you just tell me the 4 factors of production, or rather 3, if you can name them? Yeah, land, labor, capital, land, labor and capital. Okay. Yes, that's correct. So out of these factors, labor is the only factor of production which we can vary in the short run. We can only increase the quantity of the labor available to us. Okay. Capital cannot be changed in the short run, and same as land. The land at our disposal will remain more or less the same. So now we come to the second part, that is the producer's equilibrium. So what is the meaning of this? The ultimate aim of any firm is to earn the maximum profit possible. That is what every firm looks at. Their target is earning maximum profit, and that maximum profit will be given by what? When can we have a situation of maximum profit? Rajiv, Kelvin and Prabha? Okay, all that that's fine, Prabha. Okay, that's very good. Full utilization of the capacity of the firm, or reaching the optimum level of production. Okay, the optimum level of production, or making the best use of the available resources, or we can say when the costs are minimum. When the cost of production is minimum for the firm, that is a situation of cost of production is minimum. So that is the situation of profit maximization. Yes, when the cost is minimum, then definitely our sales will be higher and we'll be in a position of earning more profit. Good evening, Muhammad. So we have just started with this topic. Please pay attention, because this is in continuation to one of the previous topics, and I don't think you have attended the previous class, so you might be a little like confused. So please be very attentive. Okay. So the producer equilibrium is a situation of profit maximization. So at equilibrium, the firm has the maximum level of output being produced and earning the maximum profit out of the same. Alright, the firm has the maximum level of output. So it is the equilibrium level of output which the producer will produce at the minimum cost and sell to earn the maximum profit. Alright, So this is the situation for producer's equilibrium. Now how this situation is arrived at, or how does a producer knows when he should stop his production? He has reached the optimum point. That is the thing which we are going to discuss today. Okay. So for studying the equilibrium of the producer, we need to know about two things. There are two things which are very important. One is the isocost and the other is the isoquant. Okay, isocost and isoquant. These are the two things which we need to study about the equilibrium of the producer. Anyone has any idea about isocost? What is isocost? Okay, I'll tell you. Iso means same. Okay, the word iso means same. So isocost itself means just a second. Just a second. The signal is weak now. It is red now. Can you hear me properly, everybody? Yes. Okay. Let's continue. So word iso means same. So isocost means of the same cost, and isoquant means the same quantity. So isocost and isoquant are two things which are important in this analysis. Now what is this isocost? Isocost is a line, it is a type of graph which has got a line in it, and that line is the line which shows the cost of the factors of production which a producer will incur in the course of production. Okay, like what is the cost for the producer when he is thinking about manufacturing? Land is there, then labor is there, then capital is there. Okay, capital, or I can say money is there. So this land, labor and capital, it has got cost of its own. Let us leave land aside because land is a one-time investment that can be attained once. Let us just keep that aside. Let us discuss about the labor and the capital. So what is the cost of labor? Cost of labor is the wages which we pay to the labor. Labor is not free for us. We have to pay wages to the labor, isn't it? So that labor, the wages is the cost for the labor. Okay, is it clear? Okay, then for capital, what is the cost for capital? Can you tell me? Suppose if a producer is short of money, he is not able to meet all his requirements out of his own resources, then he might just borrow money from the market. Yes. So he might just get, he might have to pay interest on that money. Okay. So that interest will be the cost of the capital for the manufacturer. Now there is one question. If the producer invests his own money into the business, then what is the cost for capital? If he is using his own money, then what is the cost for that? Can you tell me? Equity. No, Rajiv. Prabha, Kelvin, Muhammad, any idea? Okay. So when the manufacturer is using his own money into the business, then what he is doing is he is investing his money into the business instead of keeping that money in the bank. So if he is going to keep the money in the bank, he is going to earn interest again from the bank. Yes, returns on capital, he is going to get the interest from the bank. So again, interest is the cost of capital for the manufacturer. Even if he is using his own money, he is letting go the interest which he might have got from the bank if he had invested the money into the bank, if he has made an FD of that money. Okay. So in any ways, he is the cost of capital is the interest which the producer is paying. Got that? Is this clear? Okay. Just a second, I'll get my charger. My laptop is getting discharged. So that is the cost of the factors of production for the producer. Labor and capital are the two factors which can be varied in the long run, and practically land can also be varied, but we focus on labor and capital only. So now we are going to study the production with the help of labor and capital. So let us start with this. So to explain the producer equilibrium, both isoquant and isocost has to be analyzed. Just a second, I'll get back to this. I just slipped to that. So I was telling you about isocost. So isocost is a line which shows the cost of the different combination of the factors of production which we are going to use. I'm making a rough drawing over here. Like this is the x-axis, this is the y-axis. Okay. Now, Prabha, we'll go on to that. Just a second. For that, we need to know about isocost and isoquant. Okay. So now, this is isocost. This line is the line of isocost. This is a line which is showing us the cost of, just a second. L, A is for labor and K is for capital. So for K, the cost is the interest. Okay, cost is interest, and for labor, the cost is wages. So on the x-axis we have plotted the wages, and on the y-axis we have plotted the interest of the capital. So these are the two costs which the manufacturer will incur in the process of production. We are not talking about raw material and all. Okay, we are just talking about the factors of production right now. So now isocost is that line which shows equal like same amount of money. So, because every producer is bound by a budget. He has a budget of his own and he has to make the thing done in that budget only. So suppose his budget is $1,000. Okay, so any combination of capital and labor which he is going to use on this line will be within this 1,000 rupees only, $1,000 only. Okay, at this point, if we talk about this is the extreme point. At this point, it is assumed that he is investing all the money on the capital, and at this point it is assumed that he is investing all the money on labor, that is wages. He is not taking the capital into consideration at this point. So whatever may be the case, it is a line which shows the equal level equal amount of money that he's going to invest on the factors of production. Okay, like suppose if I talk about this point, at this point it might be like 500 for the interest and 500 for the labor. If I talk about this point, it might be 100 for the interest and 900 for the labor. Prabha, it will be actually a combination of wages and interest. Okay, the combination in total will always be $1,000. All right, it may be 900 rupees on wages and 100 on interest, or it can be 200 on interest, 800 on wages, whatever. The total should always be 1000 only. That is what an ISO cost line shows to us. Alright, Rajiv, Kelvin, Mohammed, Prabha, is it clear? ISO cost? It is practical, Prabha. It is practical, but when it comes to practicality, it is used in modified form. Okay. On paper, we make adjustments. On like scale, we use 1 unit is equal to $500. That is the scale that we use. Now, next heading is ISO quant. Now, what is this ISO quant? ISO means same and quant means quantity. So it is a graph which shows the same quantity of output that will be manufactured using the various combination of factors of production. Okay, now if I draw it, it will be in the shape of a curve like this. Okay, so like this is total. I'll say 200, sorry, total is 200 units. Suppose 200 units. It is Q. Q means the total output. So Q is equal to, you remember the equation, F is equal to Q is equal to function of L, K and LA. If you remember, in the last class we did. I'll write it over here. Q, that is output, is a function of K. K is for capital, LA is for land and L is for labor. Okay. So let us just keep it as K and L. Let us erase this LA. That will be easier. So coming back to ISO quant. So like this is for 200 units of output. Yes, Prabha, that's correct. Now this is a graph which shows the various combination of goods which inputs which we can use to get that 200 units of output. Like suppose I talk about this point. So at this point we might be using 5 capital and 1 labor to get 200 units. At this point it may be 3.5 units of capital and 2 units of labor. At this point it will be more down like this. At this point it can be something else, 4 capital and 3 labor. Alright, The ultimate the ultimate aim is to manufacture 200 units of output. All right? Is it clear? Rajiv, Kelvin, Mohammed, Prabha? So this is an isoquant. So we can say isoquant is a graph which shows the various combination of inputs which we can use to manufacture a desired level of output. Now, if suppose this curve shifts towards this side, it means we are manufacturing more units. Like initially it may be 200, it may be, next may be 300. Okay, more it is away from the origin. You understand origin? Origin is this point. More it is away from the origin, it is from the origin, higher is the level of output which we will be getting. Okay, if it's like this curve, it's 300, this is 200. Now if there is a curve which is more towards the origin, like this, it will be lower output, maybe 100 units. Yes, Prabha, but not very exactly. Okay, like suppose this all is used in the like projections, for making the projections for the firm. These all theories help in the projections. Like suppose if in this year we are going to manufacture 10,000 units, so what can be the possible need for the labor? How much capital we might need, so that the firm can make arrangements in advance. That is the target. So that is called an isoquant. Now isoquant and cost is clear. So now we can go to this. Yeah, one more thing. Now talking about the equilibrium of the manufacturer. How do we attain that level? How do we judge that? It is a point at which the isocost line is tangent to the isoquant. Okay, like they are touching each other at this point. So this is this point, maybe point P. This is the point of equilibrium for the manufacturer. All right. Rajiv, Kelvin, Muhammad, Prabha. Yes. Just a second, Prabha. Yeah, you can say desired outcome. Desired means like welcomed level of output. Something that can be, that is like feasible for the firm to manufacture in the long run. One second. I'm putting in my charger. Just a second. Give me a minute. So now I'll take you to the, you just read this. Read what is written on that slide so that we can just go ahead. So, producer's equilibrium can be explained graphically with the use of both isoquant curve and isocost line. It is attained at the point where the isocost line is tangent to the isoquant curve in the graph. So, what is an isoquant? It refers to the equal quantity. Isoquant line is the locus of points showing combination of factors, example labor and capital, which gives the producer the same level of output. Any point on this line, it is going to give us the same level of output. It reveals the combination of input to get a quantity of output. Okay. Then slope of the graph gives the marginal rate of technical substitution. Now what is this marginal rate of technical substitution? It is the ratio between the labor and the capital. Okay, like if we are doing away with a little bit of capital, how much labor we will have to increase to get the desired level of output. This is not so important, but you should just know the definition of this marginal rate of technical substitution. You can find it in the content of the book you have. Shall I go ahead? So this is a graph for isoquant. You can see there is capital on the y-axis and labor on the x-axis. So Q is the units of output which we are aiming at to manufacture. So any combination of capital and labor on this is going to give this Q units of output to the firm. That is what a isoquant shows. Now next is isocost. It refers to equal cost. It is the cost of purchase of two factors of production in a budget. Okay, like every firm is bound by a budget. So keeping that budget in mind, the cost of the two factors has to be judged. The best one, the best cost, the best combination has to be judged. So isocost line shows the locus of points showing the combination of inputs that can be purchased with the available budget. Alright. So the slope gives the ratio of wages and the rate of interest. Slope is equal to W upon R. W is for wages and R is for the rate of interest. We are not very concerned about the slope. We need to focus on the theory only. So this is this is an isocost line. You can see 8 units of capital, 0 units of labor. Okay, when 6 units of capital, 3 units of labor, 4 units of capital, 6 units of labor, 2 units of capital, 9 units of labor, 0 units of capital, 12 units of labor. So the ultimate is the total is 12. Okay, just look at this point. Let us assume this is 7. Okay, sorry, 9. No. Sorry, I am telling you the wrong thing. It's not very well plotted. Let's go ahead. Yes, Prabha, what is that? 7? 0.7, yeah, okay. So now, coming to producer's equilibrium, it is attained at the point where the isocost line is tangent to the isoquant curve. So it is the point where the isoquant curve just touches the isoquant line. It doesn't intersect the isocost line. As we have seen in the case of consumer theory, the consumer's equilibrium, we have seen, you remember the indifference curve analysis when there were different combination of goods that were used. So in that also we saw a similar type of a thing. So it is very similar to that only. Isocost doesn't intersect the isoquant curve. It just touches it at a point. It is just tangent to it. So slope of the isoquant curve and isocost line are the same at this point, and marginal rate of technical substitution is equal to wages upon the rate of interest. Any doubts? So look, this is a graph which shows us the producer's equilibrium. This is the isoquant and this is the isocost line. This is the curve, this is the line. So at this point the consumer is in equilibrium at pink point, because it is the point at which the two things are touching each other, the curve and the line, and the marginal rate of technical substitution at this point is W upon R. Alright, this is the point which is going to give the maximum benefit to the manufacturer. Kelvin, it's not break even point, because break even point is the point of no profit, no loss, isn't it? So this is not that situation. This is the point at which the producer's the cost is minimum for him, and the resources are optimally utilized. That is the best point for him. Okay. So this is one thing. Now, for profit maximization, there are two methods. We need to know about this one, isocost and isoquant method. This is what I told you, how this analysis is used for the purpose of calculating the slope of the, calculating the equilibrium of the consumer. Profit is maximized when the slope of isoquant is equal to the slope of isocost. This is another method, but this we will be studying when we are talking about the marginal revenue and marginal cost. That is a separate chapter in itself. So now here is another graph which is showing the same thing. This AB is the isocost line, CD, EF and GH. There are 4 isocost lines. So AB is the line with a lower level of, or we can say lower volume of cost. Then there is one isoquant, and this isoquant is tangent to just one line, is tangent to line CD at point Q only. So point Q is the point of equilibrium for the manufacturer. He is getting 400 units of output, and he is using N is the volume of capital and M is the number of labors which he is putting in. So this NM combination is giving him 400 units of output at the point Q, he is at equilibrium. Alright. Now delta y upon delta x, delta means the change. So change in factor y upon change in factor x is equal to the price of factor x upon price of factor y. Okay. If like the price for labor is 600, so it will be price for labor is 600 and price for capital, the interest which he'll have to pay, maybe 50 rupees per 100. So this is per 1000 rather. So this we are going to calculate 5 ones are 5, 12s are. So if anybody says what is the marginal rate of technical substitution here, the answer is 12. Okay, wages upon the rate of interest. So wages is 600 per labor and 50 is the rate of interest. So 12 is the marginal rate of technical substitution. Alright.
अपनी क्लास को उससे लॉगिन करके ले लो ना, ये बची हुई है इससे ले लो, प्रॉब्लम होगी।
Yes, Prabha, you don't have chart of LA, MP, AP or not required for this, only labor and capital. Yes, we require labor and capital for this one. Okay, we require actually ISO quant and ISO cost for this analysis. That total production, marginal and average production we did in the previous class, na? That was for one factor of production. When we are talking about two factors, we do only for ISO cost and ISO quant. Okay, so the and one thing, there is some problem in the laptop which I am using right now. So I am using I'm logging on to other laptop. So I'll be just logging out for a while. Okay. So I'll just continue till the time I'm logging in through that one. So this is the explanation for that graph. In the graph above, CD is the ISO cost line that is tangent to ISO quant curve 400 units at point Q. So the firm employs OC units of factor Y and OD units of factor X to produce 400 units of output. Let us get back to that. So they are telling us the same thing. OC the factor Y, OD factor X. So now looking at that graph, in that graph any point below Q on the ISO cost line AB is desirable as it shows lower cost, but it is not attainable for producing the 400 units of output. Okay, any point just any point above point Q, any point below point Q is desirable because it means lesser cost. If the point is somewhere here or somewhere here below Q, it means lesser cost to the firm. But with that point, we cannot get the 400 units of output, which is the target of the firm. Okay, and if any point is beyond Q, then that would mean higher cost to the firm. So that higher cost is also not needed by the firm. They want maximum profits. Okay, so now Now these are unattainable by producer with CD budget. Hence point Q is the least cost point for producing 400 units of output with OC units of factor Y and OD units of factor X. Point Q is the equilibrium of the producer. Let us see that. As we have discussed, Q is the optimum point for the manufacturer. With ON factors and OM factors of labor, he is getting the 400 units at the minimum of cost. Now this is marginal revenue and marginal cost approach for the calculation of producer's equilibrium, but I won't be doing that because you'll get a little confused. Okay, so what I'll do is I have a video, so I'll just play that for you, and in the meantime I'll log in through the other laptop of mine. Okay, just watch the video, everyone.
Alright, so today's video actually starts chapter 3, which is the behavior of the firm. So we're trying to understand how firms make certain decisions. This is similar to what we learned in chapter 2, right? So in chapter 2, we understand how consumers behave. Now we're just trying to understand how firms behave and how they make certain decisions, alright? And we're going to use the isocost and the isoquant to help us understand this. And of course, we always begin by asking ourselves, so what does the isocost and the isoquant mean? Alright, so let's explore that into further detail. Let's begin with the isocost. The term iso here is actually a Greek word that means same. So the isocost basically translates directly into same cost. It is a graph that shows all the combinations of inputs given the same cost budget. Notice that the word same is in the definition of the isocost, and that's why it's called the isocost, right? So when a firm wants to produce certain goods, it's going to need some resources, okay? And those are the inputs that I'm referring to. In general, we're going to take a look just at two types of resources. We're going to take a look at capital, which is denoted by a capital K, and labor, which is denoted by a capital L. And to employ these kinds of resources, the firm is going to incur some kind of cost, which we denote as C0, C1, or C2, right? So this denotes the different levels of cost that the firm can actually incur. So for labor, we pay labor wages, right? So it's denoted by a capital W, and W here refers to the nominal wage. And as for capital, we actually incur a interest rate cost. Now, just let me explain why the cost of capital is actually the interest rate. It is because there is an opportunity cost of not putting this money into the bank to earn that interest rate. Instead, the firm is taking this amount of money and putting it into machines, vehicles, stuff like that to create those goods. That is why the opportunity cost of capital is actually the interest rates. Okay, so I can actually represent the ISO cost in a mathematical equation as well. It will be the total cost is equals to the wage rate times the amount of labor plus the interest rates times the amount of capital that we employ. Okay, to illustrate the ISO cost, we're going to need a graph with labor on the horizontal axis and capital on the vertical axis. It is going to be a straight line because it is we're actually referring to a linear combination of inputs, right? And the horizontal axis, the intercept, is going to be the total cost divided by the nominal wage, and this is the total amount of labor if 100% of my cost goes into labor. And this vertical intersect over here is the total cost divided by the interest rates, and it is the total capital that I can get if 100% of my cost is allocated to just capital. Alright, so I think this is pretty straightforward. Now the slope of the ISO cost is actually the wage rate divided by the interest rates. I'm not going through this in so much detail because I think by looking at all this stuff, you actually recall chapter 2's concept of the budget constraint. it is very, very similar to the budget constraint. And if you're going to compare the budget constraint with the ISO cost, let's take a look at what the budget constraint wants to do. It wants to go upwards, right? Because the consumer having a higher budget will actually let him buy more good X and good Y. However, for an ISO cost, it actually wants to move inwards. Why? Because to achieve a lower cost, you just move towards the origin, right? And that is what the firm is trying to do. It is trying to minimize its cost. We'll go into that later. Now let's talk about the ISO quant. And again, ISO here refers to same, and quant is of course quantity, so it means same quantity. So the ISO cost is actually a graph that shows all the different combinations of inputs that a firm is going to require to produce the same quantity of a particular good. Okay, just let me show you different combinations of inputs. So maybe we have 10 units of labor and 20 units of capital, or 20 labor and 15 capital, or 30 labor and 5 capital. It doesn't matter which one of these bundles, the firm can use this to produce X naught amount of goods, for example. So maybe X naught is, say, 15 units of X. If you're going to increase the quantity produced to X1 or X2, you're going to have to increase the amount of inputs that they put into the bundles, right? So in conclusion, all these bundles here can actually produce X naught amount of X. Okay, so that's what it means by the different combination of inputs that produces the same quantity of a particular good. So let's look at this in a graphical.
Thanks for watching a sample of the Quickonomics online learning experience. We hope you've enjoyed it. We believe that true happiness lies in realizing ambitions and dreams. That's why we make our products specific to your needs, simple to understand and captivating, so that you can learn effectively while saving time, realizing those ambitions and dreams. The Quickonomics online learning experience is a range of supplementary lectures, tutorials, and exam solutions in the form of videos, which you can conveniently view anytime, anywhere. Watching our videos before and after your regular lessons at school, we aim to give you joy in learning and build academic confidence at the comfort of your own relaxed learning environment. So how can you begin? We welcome you to purchase Quickie Dollars to redeem the videos for full access to the Quickonomics online learning experience. Thank you for starting with Quickonomics.
Alright, so today's video actually starts chapter 3, which is the behavior of the firm. So we're trying to understand how firms make certain decisions. This is similar to what we learned in chapter 2, right? So in chapter 2, we understand how consumers behave. Now we're just trying to understand how firms behave and how they make certain decisions, alright? And we're going to use the ISO cost and the ISO quant to help us understand this. And of course, we always begin by asking ourselves, so what does the ISO cost and the ISO quant mean? Alright, so let's explore that into further detail. Let's begin with the ISO cost. The term ISO here is actually a Greek word that means same. So the ISO cost basically translates directly into same cost. It is a graph that shows all the combinations of inputs given the same cost budget. Notice that the word same is in the definition of the ISO cost, and that's why it's called the ISO cost, right? So when a firm wants to produce certain goods, it's going to need some resources, okay? And those are the inputs that I'm referring to. In general, we're going to take a look just at two types of resources. We're going to take a look at capital, which is denoted by a capital K, and labor, which is denoted by a capital L. And to employ these kinds of resources, the firm is going to incur some kind of cost, which we denote as C0, C1, or C2, right? So this denotes the different levels of cost that the firm can actually incur. So for labor, we pay labor wages, right? So it's denoted by a capital W, and W here refers to the nominal wage. And as for capital, we actually incur a interest rate cost. Now, just let me explain why the cost of capital is actually the interest rate. It is because there is an opportunity cost of not putting this money into the bank to earn that interest rate. Instead, the firm is taking this amount of money and putting it into machines, vehicles, stuff like that to create those goods. That is why the opportunity cost of capital is actually the interest rates. Okay, so I can actually represent the ISO cost in a mathematical equation as well. It will be the total cost is equals to the wage rate times the amount of labor plus the interest rates times the amount of capital that we employ. Okay, to illustrate the ISO cost, we're going to need a graph with labor on the horizontal axis and capital on the vertical axis. It is going to be a straight line because it is we're actually referring to a linear combination of inputs, right? And the horizontal axis, the intercept, is going to be the total cost divided by the nominal wage, and this is the total amount of labor if 100% of my cost goes into labor. And this vertical intersect over here is the total cost divided by the interest rates, and it is the total capital that I can get if 100% of my cost is allocated to just capital. Alright, so I think this is pretty straightforward. Now the slope of the ISO cost is actually the wage rate divided by the interest rates. I'm not going through this in so much detail because I think by looking at all this stuff, you actually recall Chapter 2's concept of the budget constraint. It is very, very similar to the budget constraint. And if you're going to compare the budget constraint with the ISO cost, let's take a look at what the budget constraint wants to do. It wants to go upwards, right? Because the consumer having a higher budget will actually let him buy more good X and good Y. However, for an ISO cost, he actually wants to move inwards. Why? Because to achieve a lower cost, you just move towards the origin, right? And that is what the firm is trying to do. It is trying to minimize its cost. We'll go into that later. Now let's talk about the ISO quant. And again, ISO here refers to same, and quant is of course quantity, so it means same quantity. So the ISO cost is actually a graph that shows all the different combinations of inputs that a firm is going to require to produce the same quantity of a particular good. Okay, just let me show you different combinations of inputs. So maybe we have 10 units of labor and 20 units of capital, or 20 labor and 15 capital, or 30 labor and 5 capital. It doesn't matter which one of these bundles, the firm can use this to produce X naught amount of goods, for example. So maybe X naught is say 15 units of X. If you're going to increase the quantity produced to X1 or X2, you're going to have to increase the amount of inputs that they put into the bundles, right? So in conclusion, all these bundles here can actually produce X naught amount of X. Okay, so that's what it means by the different combination of inputs that produces the same quantity of a particular good. So let's look at this in a graphical.
Thanks for watching a sample of the Quickonomics online learning experience. We hope you've enjoyed it. We believe that true happiness lies in realizing ambitions and dreams. That's why we make our products specific to your needs, simple to understand and captivating, so that you can learn effectively while saving time, realizing those ambitions and dreams. The Quickonomics online learning experience is a range of supplementary lectures, tutorials, and exam solutions in the form of videos, which you can conveniently view anytime, anywhere. Watching our videos before and after your regular lessons at school, we aim to give you joy in learning and build academic confidence at the comfort of your own relaxed learning environment. So how can you begin? We welcome you to purchase Quickie Dollars to redeem the videos for full access to the Quickonomics online learning experience. Thank you for starting with Quickonomics.
Okay, so that's what it means by the different combination of inputs that produces the same quantity of a particular good. So let's look at this in a graphical.
Thanks for watching a sample of the Quickonomics online learning experience. We hope you've enjoyed it. We believe that true happiness lies in realizing ambitions and dreams. That's why we make our products specific to your needs, simple to understand and captivating, so that you can learn effectively while saving time, realizing those ambitions and dreams. The Quickonomics online learning experience is a range of supplementary lectures, tutorials, and exam solutions in the form of videos, which you can conveniently view anytime, anywhere. Watching our videos before and after your regular lessons at school, we aim to give you joy in learning and build academic confidence at the comfort of your own relaxed learning environment. So how can you begin? We welcome you to purchase Quickie Dollars to redeem the videos for full access to the Quickonomics online learning experience. Thank you for starting with Quickonomics.
Okay, so here what I'm doing is I am connecting all these points, or putting all these coordinates, K and L, in an X and Y plane that has L in the horizontal axis and K in the vertical axis. So here's our first point, point A, 20 capital and 125 labor. All right, so this is A. And here's our point B, 50 and 50. Here's our point C, 100 capital and 25 labor. And here's our point D, which is 125 capital and 20 labor. Okay? And if we connect all these dots, let's do this in blue, we'll get a curve that is kind of familiar to you. I bet you remember a curve like this. This looks really similar to the utility functions or utility curves we were actually seeing in utility theory. And it's not surprised we're using the same formula, same form of the function, remember? So this is what we call an isoquant. An isoquant. And it has the same properties that a utility function had, which is the slope of the curve decreases in absolute terms as you go away from the origin towards the L, towards the x-axis, right? And as the number of units of labor increases, right, you go down here, and the number of capital units decreases, your slope of the curve is actually decreasing in absolute terms. And that's that's the fact that labor has diminishing marginal returns. And that's what we said before, right? We said that when you have very little labor, which is a D, and you want to increase your labor and decrease your capital, you can do this by replacing 5 units of capital with 1 labor, and this is right here, right? This is this point right here. But when you have a lot more labor, let's say at 50, it will take a lot longer, a lot more to actually replace that capital with labor. Right? At that point, you will need 75 units of labor to replace only 30 units of capital. So the fact that this isoquant has a diminishing, a smaller slope in absolute terms as the number of units of labor increases reflects the fact that labor has diminishing marginal returns, and the same for capital. As you increase the number of units of capital, the slope is going to get larger in absolute terms because you will need more capital in order to replace a lot less units of labor. All right, so we are gonna. This is the curve we're going to be using in order to study production. Now, another thing you should notice is that all these combinations of labor and capital give you 50 units of output. That means the same way in which one utility curve has the same utility along the same curve, the isoquant will have the same unit of output along the same curve. So let's get rid of these points now here. What we're saying is that this isoquant along every point is going to give you 50 units of output. Now, the last thing it should be clear to you is that if the amount of output increases, then the isoquant is going to move to the right, right? Because let's say you can actually produce more output if you want, and since the form of the production function is the same, every time you produce more output, what you do is you move to an isoquant that is farther away from the origin but keeps the same slope. And the same thing if you produce less output. And you can try this on your own. What you can do is you try to do the numbers again, and instead of being 50 capital, try with 25. And just keep this curve in there, and solve for the same unit of capital, but this time for output of 25, and see what you find out, and see if in fact the isoquant is going to move. It should move inside.
Yes, now I am there. For a while the connection went off. For a few seconds I am there. So we'll be meeting in the next class because now the class is about to end, and tomorrow I have a class and I'll be doing the same topic in tomorrow's class as well, because this was not a like it was another person's class, like it was class of Professor Vashisth and I took that. So that is why most of the students were not there. So I'll be taking this topic again in my own class. Alright. So same class will be there, Prabha. Alright. I hope you have no problems with that, because you gave that feedback now, no repetition. It was repeated because I took the topic in others' classes. Okay. That is why I repeated. Rajiv, it will be good if you will attend. The concept will be much clearer. Okay. It will be clearer to you and it will be good for you if you will attend that. That's fine. Alright, Prabha, no problem. So we'll be meeting in the next class, and hope to see you all in the next class. Okay, bye then. Take care. Good night.